right. Thanks so much. As Steve mentioned, we are going to be covering in the next couple of months some topics related to accelerated searching in Splunk. So in May here, I am going to kick it off talking about specifically searching with tstats. So always happy to answer questions. If you have anything, please feel free to put it in chat, Q&A, and I'll look for those toward the end of the session. So we will get started here. During today's talk, we are going to focus on the tstats command. We'll talk about some basics in what tstats does, what it is intended to do, and some of the options, the structure of the command syntax for using it in different scenarios. So that will be really just an introduction. And the more hands-on aspects, we will be talking about using default fields in Splunk, which I think is overlooked a lot of times by administrators, and a great way to start using tstats. I want to get some more specific use cases, diving in, showing tstat searches in action with some example data that we have today. At the end, I'll loop around and talk on tutorial data is something that you can have access to, can download and put in your own Splunk environment to do the exact exercises that I'm going to be showing. And then rounding it out, we are going to talk about just a little bit of an introduction before the next session, data models, what they are, and normalization, how that's going to help us run some tstats queries on our example data today. So before I jump in, I do want to mention some great additional resources. If you're interested in this, I'm going to be keeping it pretty high level and introductory. But if you want to go behind the scenes and understand what's happening under the hood when Splunk is running these queries, then you can check out these great Splunk.conf talks that I've personally used as resources in learning these topics. So highly recommend that you check these out. Please follow up after the presentation if you're with us live or you are tuning in later. Happy to share out these slides and resources so that you can start working on them yourself. All right, so starting with the tstats command is very aptly named. Tstats is going to be helping you with statistical queries. You'll always be having a statistical function of some type that is going to provide some interesting output on your data. It's not going to be the standard working through your index and then specifying down fields, getting event views. You're always going to have your tabular statistical output as the initial output from the command. So generating in that sense. Tstats uses indexed fields. And so what we will be seeing in our first examples are default fields, fields you're most familiar with in working with Splunk. It's going to be for all data, your index, your source type, your source, your host. I'm going to get into some more details on default fields just because they're very interesting to work with. And you can get some great information from any data set in Splunk across any environment. You can also have custom indexed fields. So this is just down to configuration when data is being indexed. I've provided in the slide here a link to Splunk documentation on setting up index time field extractions and just understanding this topic a little bit more. The last thing that we'll talk about using tstats for is querying data models, and that is both accelerated and unaccelerated. I'll save that for the end, but I think it's a really great way to start expanding a lot of what we see as introductory security use cases in learning about how correlation searches work in enterprise security and how they're starting from data models. There are plenty of other applications, and we'll get a great example today. So let's take a quick look at an example tstats command. Now, this is not going to work in any particular environment. We'll just sub in the field values as we go through examples today. But I want to call out these 4 different sections. The first is going to be starting the tstats command. As I mentioned, it's a generating command. We're going to start with a pipe tstats, and then you will have your statistical function, what is ultimately going to give you your output. The next section is a from clause. The from clause, if you are using a data model, is going to let you specify what that data model is and the root data set that you are deriving data from. So I'll talk about that a bit more as we cover data models, but very helpful to be able to reference a larger concept that may incorporate multiple data sources. The third section is the where clause. And this is what I find in any general use of the tstats command to be probably the most flexible and helpful, dependent on the situation and what I'm trying to get out of my results. And so this is where you would use what you're already familiar with in SPL logic for your filtering conditions to limit down the data returned. And you'll start to make sense of translating a typical index targeting query to a tstats query in these first few examples. And so I'm excited to show that off. The last section here is the by clause, and that's going to work exactly how it would in other statistical or charting functions. And that is really just going to split your results across values of a particular field. So I would say of all the portions of a tstats command, that's going to be the most familiar and just dependent on your scenario if that ends up being useful to you. I do want to call out that any of the second, third, or fourth sections here are optional based on the scenario for your search. You ultimately do have to have some combination of them to target data appropriately to return some results. And you'll start to see what that means as we go through examples. But just take a look at the example here, see these different sections, and do recognize how flexible this is for your searching scenarios. So I do want to highlight the statistical functions. I'm going to use count for quite a few examples. I think that is what I would say I see most in the wild as well. Just trying to get an idea, summary of what's going on in terms of volume for particular events. But you do have a lot of options for statistical functions with tstats. Now, this is select across all of the available functions, the stats functions for Splunk. So definitely do check out the search reference page that I've linked here to see what is supported by tstats. But you'll recognize many of these as probably some of the first that you would be using are common aggregate functions like count and average, the values function for returning multi-value fields, first and last for event ordering, and then time-based fields, which I think are very, very useful in understanding, especially as a Splunk administrator, what's going on in particular indexes. So before I dive into examples, I am going to cover this concept of default fields, and we will start our examples by using them. Default fields are indexed fields that are automatically added to any event data. So I talked about tstats leveraging indexed fields. Default fields are prime examples of what you would generally be using in tstats queries. There are three general categories for default fields. There are internal, which are going to be things like underscore time, underscore index time. And these are used by Splunk processes, Splunk internal processes, but very flexible. And I find that I use them a lot, especially the time fields. The basic default fields are the category that is going to contain, I'd say, what everyone is most familiar with working with Splunk data. That's going to be your index, source type, source, host, etc. There are quite a few, and I do recommend checking. Documentation has great tables on the extensive list of what you can use. The last category is default date time. I would say I don't see these used very frequently, but they can be incorporated into searches and based on your use case, may be very helpful. These are going to be all your fields that maybe you didn't expect to see as you go through your event view, but you're going to have that long list of date underscore month, date underscore day. And those are all available to be used with tstats functions. So they are considered the default date time fields. So I keep going back to this idea that these are so useful in any Splunk environment. And the way that my team uses tstats queries most frequently is through fast administrative queries just to get ideas of what's happening with a particular index, if it is understanding volume of events across unique source types, or understanding the last time data reported for a particular index. These are all things you can do very, very quickly with default fields. So we will dive into our first example here for default fields. So I'm running my query over the last 24 hours. This is a small test environment, so I'll try to highlight how quick these tstats queries are, but just keep in mind this is small volume data, and you will see ideally much more dramatic effect and impact on your searches as you run these types of tstats queries in your own environments. So what I'm doing here, may do this for any particular index, is I want to search that index. I want to see the number of events by source type over a given time period. This gives me a really clear idea of what are my heaviest hitters. In a scenario, maybe it is firewall logging. You may have really a high volume source type that's focused on traffic, and you might have some device configuration and health logs coming alongside that are falling into a different source type. You know that that's not going to make up the most of your data, but you really want to understand what is the bulk of the volume you're working with. What do you have available to use in all of your queries? So, and you may end up doing this in more targeted queries on the index after. I just like to start with the tstats. So here I'm starting with index internal stats count by source type. Very simple query, and we can see that ran in almost 0.9 seconds there. I'm going to jump to the tstats version of this query, and I'm going to take some time to explain the syntax here. Slight adjustment, but still very simple. We're going to start with our pipe tstats. We have our stats function, which is count. Our where clause is actually going to specify our default field that is helping us target the data. So in this case, it is index equals underscore internal. And then I want to split out by source type. So you can see exactly like from the first search, I'm targeting the internal index. I want to do a count across individual source types. And so with this query, we'll run it one more time. And our first ran in 0.9 seconds. This is 0.2. As you expand the volume of data, you're going to see that this is an exponential impact on your user experience for searching large volumes of data. So get the exact same results. And if this was the output you were wanting, getting the idea of Splunk D here is our most common source type in the internal index. It was a very quick way to get to that information. So our next example here, we have identified this particular source type. We want to understand some more information about what's going on. We want to search the internal index, our Splunk D source type, and then for our stats, we're going to use a time function here. And we're going to look for the latest underscore time value. And then I'm going to rename this so it's a little easier to work with. But I want to do that by host. So if you're looking at your internal index or Splunk D logs, you want to see the last time something reported. You all may be familiar with that exercise in enabling new forwarders or forwarders going offline. And you want to see the last time that it was talking. I definitely encourage the use of forwarder awareness for that exercise because it makes it a lot easier. But if you're digging into these internal logs, you really have some flexibility in seeing the latest time reported here. So I'm getting these results back. This is still a pretty quick search. We are focused on the Splunk logs. So of course, specifying as many parameters as you can to filter down on your data is going to make your query much quicker. But let's look at the tstats format for that exact same query. So we're starting pipe tstats, and then we are doing our statistical function here, the latest time, again, renaming for convenience. And this is where I'm inserting my default field specifications, are filtering down with the where statement on the internal index and the Splunk source type. I want to split this by host. And then you probably saw in the first, I'm adding this convert line here just so that we can get an idea of what these latest times reported are. And you can see that in my test environment here, before I renamed it to Lunch and Learn, got a few different host names. And we are actively getting logs here at 2:16 Eastern time. So this was also a quick query. Looks like, yeah, about 20% of the time. So these are just quick examples of ways that you can search very common Splunk data types, whether it be internal logs or just across any index, getting that general information about the logs being sent to the index. So I will prep our first example here, and I'm going to go quickly through a slide, and we're just going to go right back into search and reporting. But in our example SPL, I'm going to be focusing in on a handful of outcomes that I want to achieve. Whenever I'm writing a search, there's a good reason for it, and I have in mind what my output will be as I go to craft that query. So I'll just go through the list quickly here. The first one is going to be identifying the source types available in example indexes. I already covered through the internal index really what this is going to look like if you wanted to understand the volume. Make a slight adjustment there just so we can get a different view. I do have some data with indexed fields where we'll be able to do some work calculating revenue across particular game titles. If you all have been through the Splunk training courses, using some probably familiar data there, talking about the sales of particular video games. And then the last example, we're going to look at HTTP status codes for different purchase actions. So get an idea if there are particular errors across different actions in web logs. All right, so starting out, I have my tstats query here, and this is not doing anything different from what we have seen in the previous queries, just counting where our index, and I've chosen an in parentheses here, across our two indexes that we'll be working with today, tutorial and prices. I want to count by the index. So I can see that I have a handful of events in prices. I have a few more in tutorial. So running this, making sure we're up to date here. We are able to go through and see in the prices index. I'm going to jump back and just show what this data looks like. Our prices index is going to have a couple of fields here that we're interested in. And we're going to select our product name and our sale price. So our scenario is that we have a sale over the weekend. We complete sales at sales prices across particular products, and we want that summary of what has been happening. So we're able to run our tstats query, doing our stats over sale price. So the sale price for individual items is going to change a little bit based off of this field. We want to sum across those updated prices for the sale weekend. This is all information in our prices index and splitting it across the product name. So you can see that we had a sale total of $41.99 on Pony Run. So a successful sale weekend for that game. All right, so this is a very basic query here. And just as a reminder, our final outcome we want to achieve is seeing the status codes for different purchase actions in this tutorial data. So if we look at the tutorial index, we will see that we have a handful of fields across web logs. We want our status field, and we want our action field. So you can see we have quite a few different actions that we might be interested in writing more specific queries on. We're going to have a lot of expected HTTP status codes. And so if I reinsert my tstats here, you can see counting across the index, no problem. And if I just want to start by counting across the events with particular status, you'll see that I get 0 results. So this is something I really try to highlight early on as you're searching with tstats, because you might find unique data sources that have more fields available than you might generally expect. You're not doing anything special with data models. You're just directly searching with a where statement on the index. And so there's a distinction to make between the prices index and this tutorial data. The tutorial data was ingested, let's say a more standard method. Its only indexed fields are the default fields. This command is walklex, and I don't want to spend too much time focused on this. It's very helpful as a resource for understanding what fields are indexed across any data set. You do need some administrative privileges, just RBAC configuration to be able to run queries like this, but it can be good as a quick glance to see what I have available. So in my tutorial data, you'll see that these fields are all the default fields that I've been talking about previously. You see in the prices data, I actually have the sale price and the product name, the fields that I used in my previous query. So prices was ingested in a way that I had index fields apart from the standard default fields that allowed me to use them in tstats queries. So I try to call that out as quick as I can, just to show that this query gives no issue, while our query for the tutorial index was unsuccessful. Now, I want to talk a little bit about data models, and we're going to loop back around to see how we can make use of this tutorial index data with a full tstats query to get that outcome that we wanted in the first place. So just get set up here. So many of you are probably familiar with data models. I would say most environments, especially working with my team, you will have the Splunk Common Information Model add-on. Just to take a step back and talk about data models conceptually, this is going to be a structured domain-specific model for common data types. So as you bring in logs from different sources, whether it be maybe you're pulling from both Azure Active Directory and you have local Windows security logs, you're going to have the same concept of authentication. And you want to, across those log sources, be able to write queries that are giving you results about the, say, failed versus successful authentications within your environment. So the data models allow us to look across a wide variety of these domains, identify where our data belongs so that we can write queries more generally against that type of data. And there are some interesting configurations and things that we'll be getting into in the next session that can help you work more with data models. I'm going to keep it pretty surface level today. The second point here I try to stop any time that we talk about correlation in searches. I'd say most frequently that would come up talking about enterprise security. Out of the box, you're going to have a lot of correlation searches that are intended to look across the environment and pull these conceptually potential security risks or security events that you want to be made aware of out of all of your data. And the way that that's working, if you dig into all of the correlation searches, is for the searches to be using data models. Many of them use tstats. Some of them use a syntax that I will show as an example, and also a great tool for exploring your data model data using the from command. So correlation searches are built on this idea, using the data models, filling all the data models with the unique data types that apply to them. And those data models that you're generally going to be using are provided by the Splunk Common Information Model add-on. So as I set up this test environment, I install the add-on really as a default. I'm generally going to be using it at some point or another. So the most important thing as you're thinking about using data models and getting started with data models is that you're going to have a few steps to make sure that the data is, number one, associated with the data model, but number two, that it lines up in a way that it's going to be universally accessible by using the tstats from data model syntax. You want to make sure that the fields are usable to get those insights. So we need to do a little bit of work for our tutorial data with web logs to show us that status in the action fields. So the process in doing that, now we do have the convenience that we have some very nicely named fields in the tutorial data. Generally, it would be much more of a process to go through Common Information Model data normalization. So we want to take whatever exists in our data sets and align that with fields in the data models themselves. So in the case that across multiple types of web logs, I may have error codes in a field that is called, for one source type, it's HTTP status. For another, it is response code. Ultimately, they're going to mean the same thing. And I need to make that alignment so that we can use what is the status field in the web data model. So providing that consistency really allows you, as you get used to the data models that you work with most often, it really helps you to write queries more efficiently and more effectively. And also knowing as you bring unique data in, it gets easier and easier to take the steps to align your data sets with the data models. There are two ways that you would generally do this. And I do highly recommend, if you're interested in this process, especially for enterprise security administration, Splunk's enterprise security admin class goes in good detail the process of actually aligning data with a data model, normalizing the data. So they talk in detail about aliasing, which is very simply just creating a new field with the expected name, what's going to be present in the data model, and it keeps the same contents of that original field. So if I had HTTP status and wanted to also have status, I would just make an alias if that value was as expected. The other option is eval, and that would be based on the contents of a particular field. Sometimes, and you can read this in the documentation for Common Information Model and data model configuration, you'll have expected values for certain fields. And so if any particular data source breaks from that, you'll be able to write an eval statement that provides a correct output in a new field so that you can leverage that data in tstats and data model searching. Okay, so we are down to our final step here with our tutorial data, going through our checklist, making sure that it's usable. So the first step is going to be making sure an event type exists. So I already mentioned event types and tags are how you're going to associate new data sources with data models. We talked about normalization, making sure that data has expected fields. There is an additional step, which is very important in data model performance, and that is making sure that index constraints are, number one, configured at all, and number two, that they are inclusive of your target index that you want to be working with, searching through the data model. And then the last piece, and this is really important for actually writing your queries, is recognizing the data sets within the data model that you want to be using. So I'm going to cover all of those, exploring in Splunk here. I want to take a look first at the tutorial data. And as we saw earlier, we have our action field and we have our status field. So these are already in the data. If maybe they had different names, we might need to create some aliases. Thankfully, we do not. We know that those are going to be what we use for writing these queries. The event type for aligning our tutorial data with web is going to be looking for a specific source type. We have a handful of source types available in this data. We have vendor sales and the access combined logs. Access combined is actually the data that contains this information about the status codes that we want to be using. And so for our event type configuration, we are looking for our source type of access combined with cookie. So when we match on this particular source type, we're going to get a web tag in these logs. And you can see here in our tags in the interesting field, across, it was the same number, 369 for the source type. You're going to see web. All right, so we have our tag applied, our event type is working, and we do want to make sure that the index constraint is set appropriately. Now, I want to jump to the data model to explain this just a bit more. We're looking at the web data model from the SIM app, and you can see at this base or the root data set, we have a single line of constraints. So what this is doing is effectively giving us an implied filter for the data model as we use it. This is what it is searching on to return us events. So for the indexes, we want to set this macro to our expected value to be able to use the tutorial data. And we also are only going to be returning our events that have the web tag, so just our access combined events. So we see in the SIM web indexes, this is a common naming scheme. So if we look at our common information model macros here that were created within the app, you can see that there's going to be a macro like this for every data model. So as you're working with, say, endpoint, email, any individual one here, then you can come in and set your indexes appropriately. So I'll search back on web, and you can see that I've gone here and added my index. And you might say I had our prices index also included there. This would allow us to be searching over that as well. So I am going to cancel out here. We know we have our index set. And that brings us to our last point here, which is identifying the data set for use. So if I had a particular need to use proxy logs or storage logs, you can see that there are additional constraints for each of these, and you would configure your event types, or the add-ons that you install may already provide some unique tags for specific types of events. In my case, I'm just using the web tag, and I'm going to stay at the root level of this data model. And you can see that I have in my fields a status and action. So status and action here. So everything is configured, and that means we can jump over to our web data model data. I mentioned this is a great tool for being able to search data models, the pipe from command, and then the syntax data model : and entering in a data model name in double quotes. I think this is a great way to explore sample data as you're writing queries. So you can get ideas of the fields that are available to you through the data model, what you have data available in. So in our case, I'm not going to have a considerable amount of data to work with. And I've already identified from my outcome, I really want the action and the status. And so I can see here in searching the web data model that I have these available. And you can see as you're exploring this, as you populate your data models more fully, then you can see the individual source types that are contributing here. And you do have the option to further filter down in tstats queries using both data model and additional where constraints. So if you really specifically wanted to target, in this case, access combined logs, you'd be able to do that. So we're going to start again with our query that we tried before. It doesn't work. Status isn't an index field. We can't use it. So I'm going to go back from my tstats count. If we remember the syntax, I want to include from data model, and I am going to be using web. So let's just run a quick search here. I'm counting across the last 24 hours for my web data model, and I'm getting 111 events. We will also, and this is what I mentioned about using the root data set. If you were to include child data sets like proxy or storage working through that tree, there is some more advanced syntax for specifying particular node names or getting to that specific data that you want to be seeing. So just keep in mind as you really dig into this, the documentation is your friend and can help you through that. Also, always happy to jump in. My team can help you out in writing those queries as well. So we're going to count from the web data model dot web root data set. And I'm going to jump back to the data model to explain this a bit more. We are actually in our web data model looking at a unique data set called web. This is somewhat consistent across the data models. If you explore some others that have multiple names, you might see that there is an underscore in between these. So this would be the value that you enter in that notation, web.web. All right, so we are looking at the web data model, and I want to count by web.status. We can see across our access combined events using tstats, we got our output that we wanted to see here, mostly 200s with a few errors. So knowing this syntax here and knowing that we have a little bit more flexibility with our where clause, I want to add in a specific action. And so if my action is purchase, I want to see what the status is for all of those. And I want to know what the most frequent value is here. And let's see. Typo on my part. I'm doing my sorting in the query, but I want to confirm that I am getting out of all my purchase actions primarily successful exchanges here. And so if you are monitoring servers, making sure that performance is as expected, that there aren't any issues. If something does happen, of course, you want to be running queries like this. Maybe you're filtering out if we look for web.status is greater than or equal to 400. We can see that we're going to get all of our errors sorted by the most frequently occurring. So know your fields, know the syntax, and you have just as much flexibility in using queries like this as you do with any other SPL. So another quick example to round this out, I am going to continue with tstats count from the web data model, and I am going to change to specifically look at status of 200, and then I'm going to use a time parameter here. If you have ever wanted to get a quick time chart of data, I find myself using this more and more. You can use _time as a parameter and index field in tstats queries, and time as a by parameter specifically will accept through tstats a span. And so if I want to, let's say we'll do 5 minutes, I can get a return on my events here. And just like that, I've created my time chart that shows a fluctuation in my successful events. So we've gone through, looked at default fields. We've looked at a few other examples using some data with index fields. We've looked at data model configuration. I highly recommend exploring the current configurations if you have permissions to do so in your environment, just to see what's happening there, potentially getting into the acceleration settings, which we'll talk about more soon. And you have gotten a bit of insight on an approach to creating tstats queries, exploring the data available in data models, and I hope that you can put this to good use in your environments. So with that, I can pause for any questions. Please feel free to type in the chat in the Q&A, I believe, and I'm happy to answer them. As I mentioned at the beginning, there is tutorial data available. If you look for Splunk tutorial data, should be the first link. And there's great instructions on how to bring that into any test environment. Running on a VM, on a container, then that's a great way to explore some of these concepts and learn ways to use it in your production environments. So with that, we're concluding for the day. Not seeing any questions. As always, feel free to reach out to me, reach out to my team. And if you would like the slides and details about the articles I referenced throughout the talk, please reach out to either me directly or support at Kinney Group, and we'd be happy to provide you with those resources. All right. Well, seeing no other questions, thank you everyone for attending. I hope you enjoyed and look forward to your attendance at the next session. Thank you.